2.2 notes are on composition of mass and of molecules and compounds. In the Foundations in Chemistry Part 2 unit, we are working on FC2, or Construct an Understanding of a Mole as a Unit for Measuring the Amount of a Substance. Our chemistry cat there says, if you're having bad chemistry problems, I feel bad for you, son. I got 6.02 times 10 to the 23 problems, but a mole ain't one. Today we will learn how to calculate molar mass of ionic and molecular compounds, and we will also learn how to perform molar conversions, including mass to mole and mass to particle conversions. When we are determining the number of atoms in a formula, it's determined by the subscript to the right of the element or the coefficient to the left of the compound in a balanced chemical equation. If there's no subscript, this means there's only one of that particular atom. For example, sodium chloride, we have one sodium atom and one chlorine atom. When we're dealing with polyatomic ions, remember that the subscript found outside of the brackets is applied to every atom inside the brackets by using the distributive property of multiplication. For example, magnesium nitrate, we have one magnesium atom, 2 nitrogen atoms, and 6 oxygen atoms, because that 2 hits both the oxygen and the nitrogen atom. We have 2 nitrogen, and then 2 times 3 is 6 oxygen atoms. Some other examples here: diboron hexahydride. We have 2 boron atoms and 6 hydrogen atoms. Lithium phosphate, 3 lithium atoms, 1 phosphorus atom, 4 oxygen atoms, and iron 2 nitrate, 1 iron atom, 2 nitrogen atoms, and 6 oxygen atoms. Molar mass of atoms is the mass of an individual atom that's given to you on the periodic table. That value is listed underneath the name, and we have referred to the units of this value as atomic mass unit. Another way we'll use from now on is grams per mole. What this means is that the value found on the periodic table is the mass for 1 mole, or 6.02 times 10 to the 23 of atoms for that particular element. Again, we also refer to this as the atomic weight, and we'll elaborate more on this later in the course, but for now, we need to make sure we realize the units for mass when we come off the periodic table can also be in grams per mole. So for example, if we were looking for the molar mass of beryllium, we would look to our periodic table, and our molar mass of beryllium is 9.01 grams per mole. If we take a look for tin, we would find our molar mass to be 118.71 grams per mole. Chlorine, if we took a look at that at our periodic table in our column 17, we would find it to be 35.45 grams per mole. And for copper, we would find our molar mass to be 63.55 grams per mole. We can also find the molar mass of a molecule or compound by adding up all of the masses of the individual atoms in the compound. This value is known as the molar mass of a molecule or a compound. For example, we have sodium chloride, and we would look both up on our periodic table, both elements, and add them together. So I often like to write these out a little bit differently. I find it the easiest. So I go sodium and put and then I would look and I would say, okay, we have one sodium. We have one sodium, and I would look up the mass on the periodic table. One sodium is 22.99 grams per mole. 1 times 22.99 is 22.99. And then we have chlorine. We'd look that up. We have one chlorine. 1 times 35.45 is 35.45. And then we add up those numbers. 22.99 plus 35.45. We get 58.44 grams per mole. For our second example here, beryllium nitride, we'd write down beryllium, and we have 3 berylliums. We take a look at that on our periodic table. Well, beryllium has a mass of 9.01. 3 times 9.01 is 27.03. And we have nitrogen here. We have 2 nitrogens. Our mass of nitrogen is 14.01. And we multiply those together and we get 28.02. And then we add those numbers together. So 27.03 plus 02. We add those up and we get a molar mass of 55.05 grams per mole. And our last example here, we have magnesium nitrate. So magnesium, we have 1 magnesium. I looked that up on our periodic table. Magnesium is 24.30. Oh, let's switch my color here. One times 24.3 which is 24.31. We have nitrogen, and we have 2 nitrogens at 14.01, which is 28.02. And oxygen, we have 6 oxygens at 16.00. 6 times 16, 96. And we add all those up, so 96 plus 28.02 plus 24.31. We get a molar mass of 148.33 grams per mole. Remember, those units are important. Grams per mole. And when we're converting from moles to mass, so why is that number important? We can use that molar mass, and if we look, grams per mole, we can use that to convert from moles to mass or from mass to moles. And to do this, we determine how many moles we have, we find your molar mass of that element, and we use dimensional analysis. So that molar mass is simply a ratio of how many, grams are in 1 mole. If we have beryllium nitride, we have 55.05 grams in 1 mole. Now, I wouldn't write it how I wrote it in our example here. I would write it as a conversion factor, just like in our previous set of notes with Avogadro or Summers, I would go 55.05 grams over a mole. Or you can write it either way, mole over 55.05 grams. Just depends on what you're looking for in your question. Well, for this question, we are looking for how many grams are in 5.4 times 10 to the negative 4 moles of magnesium chloride. Whenever we see that word grams, we know we're going to need to look up the molar mass, figure out our molar mass. So we do that first. We have 1 magnesium, and magnesium is 24.31, which is equal to 24.31. And chlorine, we have 2 chlorines at 35.45, which is equal to 70.9. And if we add those two up, we get 95.21 grams per mole. Now that we found that, we would start with our number in the question. 5.4 times 10 to the negative 4 moles of magnesium chloride. And if we have moles of magnesium chloride on the top, we are going to need to put moles of magnesium chloride on the bottom from our molar mass. So we have moles of magnesium chloride, and then our grams has to go on top, which makes sense because we are looking for grams of magnesium chloride. Our moles cancel off, and we need to go 5.04 times 10 to the 4. Sorry, 5.4. 5.4 times 10 to the negative 4 multiplied by our molar mass of 95.21, and we get an answer of 0.51413 grams. We take a look at our number in the question. It has 2 significant figures, so we'll need to round to 2 significant figures. 0.5, oh, I'm missing a 0 there. 0, write that a little bit nicer. 0.051 grams of magnesium chloride would be our final answer. We can also convert grams to moles. So in this example, we need to find out how many moles are in 15 grams of sulfuric acid. We determine what mass we have, we find the molar mass of that element or compound, and use dimensional analysis. So again, we look at our question. It says grams. Whenever we see grams, we need, okay, whenever we see grams, we need to calculate our molar mass. Well, we do that first. We have 2 hydrogens. They're 1.01, which is 2.02. Sulfur, we have 1 sulfur, and when we look up sulfur on our periodic table, we find it has a mass of 32.07. So 32.07, and oxygen. There's 4 oxygens, 16, which is 64. And then we add all those up. 64 plus 32.07 plus 2.02 is 98.09 grams per mole. And once you figure that out, we start with our number in the question. grams of sulfuric acid. And since we have grams of sulfuric acid on top, we want to put grams of sulfuric acid on the bottom from our molar mass, 98.09 grams sulfuric acid. Remembering that number is attached to the grams. Like, number does not go with the moles. It always has to say the number of grams of your element. And since grams goes on the bottom, we know moles needs to go on the top. Moles of sulfuric acid, which this makes sense because our grams cancels off from the top and bottom, and we're left with moles. We go 15 times 1 divided by 98.09, and we get a number that says 0.15292 moles sulfuric acid. But we need to look to our question, and our question has 3 significant figures, but we will need to round our answer to 3 significant figures. Take a look at that. We have 3 significant figures there. We have a 9, and the number before our third significant figure, which means we need to round up. 0.153 moles of sulfuric acid. Final answer. And a couple other examples here. How many moles are in 1.2 times 10 to the 23 grams of ammonia, or NH3? We see the word, or the unit grams. We know we need to find molar mass of ammonia. Molar mass of ammonia, we have N, and we have 1 nitrogen, which is 14.01. And you're getting very messy writing. There we go. And we have hydrogen. We have 3 hydrogens at 1.01, so we have to add that to 14.01. We add those two together, we get 17.04 grams per mole. Right there. Once we found our molar mass, we need to start with our number in the question. It is 1.2 times 10 to the 23 grams of ammonia. And since grams is on the top, we know we need to put grams on the bottom. 17.04 grams of ammonia goes on the bottom. Which means moles of ammonia go on the top. And when we work that out, we have to go on our calculator. 1.2 times 10 to the 23 divided by 17.04. And we get 7.04, but we have 2 significant figures, so 7.0 times 10 to the 21. Moles of ammonia. This next example, how many grams are in 2.3 times 10 to the negative 3 moles of calcium phosphate? This question is a little bit harder. We need to remember back to last unit where we need to figure out what the chemical formula is based off the name. So we have calcium phosphate. Again, if you remember doing that, we need to write out the charges and then swap and drop. So PO4 minus is phosphate. We swap and drop those. We have calcium 3, PO4 2. And once we've done that, we know we're going to have to find our molar mass because our question has the word grams or the unit grams. Just whenever you see grams, you're okay. I need to find molar mass. We do that. So calcium, we have 3 calciums. Calcium has a mass of, if we look it up, 40.08. 3 times 40.08 is 120.24. Then we have phosphorus. We have 2 phosphorus. That is 30.97. 2 times 30.97 is 61.94. 61.94. And then for oxygen, we have 8 oxygens that are 16, have a mass of 16. 8 times 16 is 128. And we add all those up. We get 310.18 grams per mole. We then start with our number in the question, 2.3 times 10 to the negative 3 moles. We have moles on top. We know we're going to need moles on the bottom, so we have moles of calcium phosphate over 310.18 grams of calcium phosphate. Those moles cancel off, and if we work out that answer, to go 2.3 times 10 to the negative 3 times 310.18, we get 0.71 to 2 significant figures from the question. 0.71 grams of calcium phosphate. And lastly, just to tie it all into yesterday, we can also do multiple step calculations. We can convert from mass to particles or from particles to moles. We just need to do a few different steps. We just need another set of conversion brackets in there. So it says how many grams are there when you have 1.00 times 10 to the 22 molecules. And if we remember from 2.1, molecules means we need to use Avogadro's number. So we start with our number of the question. Molecules, and we have to use 6.02 times 10 to the 23 molecules. That goes on the bottom because we had molecules on top per mole. And if we look at our question, it asks us how many grams we have, not just moles. Right now, if we cross off our molecules, we'd end up with units moles, and we need the units grams. So we need to find that molar mass. Whenever we hear grams, we need to find molar mass of our element or compound and convert it to grams. So we need to find our molar mass of water. Water has 2 hydrogens at 1.01, and it has 1 oxygen at 16. This is 2.02 With 16, we get 18.02 grams per mole. And since we have moles on top, we're going to need moles on the bottom, and 18.02 grams on the top. Which, if we work that out, we are going to have 1.00 times 10 to the 22 divided by 6.02 times 10 to the 23. And then we times all of that by 18.02, which ends up being 0.299 to 3 significant figures. So 0.299 grams of water. There we go.